The first one that we're going to do is some type of polynomial. Could be 2 terms, 3 terms, whatever. And we're dividing it by a monomial. So we're going to kind of do it like we did yesterday, where we're going to look at the different variations of it. Yesterday we had a monomial times a binomial, and then a binomial times a binomial, and just some different types. Excuse me. Thank you. All right, so in this case, on bottom we have a monomial, and we're going to divide all 3 of these terms, because we have a trinomial on top. We're going to divide all 3 of these terms by the bottom term, 7a squared. Okay, and there's a couple different ways you could do this. If you wanted to, you could rewrite it. And the most important thing is that we divide each one by 7a squared individually. Okay, now, do you have to write it out separately like this? Not necessarily, but I'm just showing you kind of the process that we actually have to go through. And if you could do the division by itself individually, then you wouldn't necessarily have to rewrite it like this, because it does take a little bit of time to rewrite. But what we're going to do is we're going to kind of remember, and we talked about all these exponent rules earlier in the chapter, but we're dividing here. Okay, so the very first term, we're taking 28 divided by 7, which would be 4. And then we have 4 a's on top, 2 a's on bottom. So we're going to be left with a to the second. The minus sign in between will stay. 7 divided by 7 is 1. Now, do we have to put 1 there? Not necessarily. Same thing with the a's. We have 3 a's on top, 2 a's on bottom. So I could just write this as a. We don't really have to write it as 1a to the first. If it's just a, then both of those 1's are assumed to be there. And then the last one, 21 divided by 7 would be 3. And then the a squareds are going to both knock each other out. And we're just left with 3. And this would be our answer. None of those things combined together. All of them are different. And that would be how we would leave it. Okay, I'm going to do one more like this. On this one, I'm not going to rewrite it. But what's different about this one is I'm going to add more variables to it. Okay, so if you like rewriting it like this up here, you can do that. Okay, it's not a big deal, but you don't have to. So really, we just got to take it one term at a time. So I'm going to take the first term on top, and I'm going to divide it by negative 5xy. So 30 divided by negative 5 would be negative 6. Okay, and then we got x's. If I have 3 x's and then 1 x on bottom, then I would have 2 x's left. And if I had 2 y's and 1 y on bottom, then I only have 1 y left. Okay, and then on this one, you got to be really careful of the signs. So now we're focusing on the second term divided by the bottom. The second term is negative, the bottom is negative, so when I take a negative divided by a negative, this would now become a positive. 45 divided by 5 would become 9. The x's are going to knock each other out because we have an x on top and x on bottom. We have 3 y's on top and 1 y on bottom. So that'd be 9y squared. Okay, and then for this last one, this is the part that is a little bit weird. Because we don't have a number here that will divide by 5 evenly, right? And so there's several different ways that we could write it. But first of all, negative and a negative is going to make this a positive. And then this is an assumed 1 right here. So I could rewrite this as 1 over 5 because there's nothing to divide. So we're just going to leave it as 1/5. And then the x's are going to cancel, the y's are going to cancel, and I don't have any variables left. And that's going to be our answer. That's as much as we can do. Okay, so I just wanted to show you that one because of the fraction. Then sometimes we kind of get freaked out because we're like, hey, wait, there's nothing here to divide by -5, and that's okay. Then we can just turn it into a fraction and write it as its own. Basically what we want to go from is having a division sign, and to now, when I write my answer, I don't have a division sign throughout the entire polynomial, even though I have a fraction right here, my division sign is gone. Kind of the same thing on top. We had a division sign to start with, we divided everything out, and now we're just left with a basic old polynomial. Okay, you might remember this from Algebra 2. I'm not teaching Algebra 2 this year, but I know I was in one of the classes the other day, and I actually had a student come and get some help yesterday that was in Algebra 2. And so I know they're doing this right now, so I know that you did this, and it was about the same time last year that you would have done this, where we're going to talk about long division and synthetic division. And I'm going to show you some long division, but we're not going to do long division a ton. We're going to do it just because there's some times where we have to do long division, but we're going to spend more time on synthetic division than we are on long division. And when we talk about long division, we can kind of remember it as something like this, way back in the day when we started doing division, right? And today we're going to see it with polynomials, but just to kind of remember the process and what everything means and stands for is if I have a number like 29 and I'm dividing it by 4, the first thing we ask ourselves is how many times can 4 go into 29 without going over? So how many times can we take 4 into 29? 7, okay? So I'm going to put 7 up here. And then I'm going to take 7 times 4, which is 28. And whatever I get underneath, I'm going to subtract that from the 29. And so we have 1 as my remainder. Okay, what does all this mean? Well, what this means is 7 times 4 plus 1 gets me back to 29. All of these things have a name to them, okay? This down here is what we call the divisor, okay? Or sorry, the dividend. This out here is the divisor. This is the quotient, the answer to a division problem. And then the one that we're probably most familiar with down here is the remainder. That's what we have left over. If we put all of these three things together, it gets us back to 29. Well, we're going to do one very similar, but we're going to do it with polynomials. And I kind of set that up just so you can kind of remember the process and the way you might remember doing it back when you started doing division of just integers or numbers. Okay, so if I had, and I'm going to leave this one up here just so we can kind of refer back to it. X squared plus 10x plus 24 divided by x plus 6. Okay, so it's written out kind of like we did on the last couple of problems, but here, because this is a binomial, I can't divide each one of those terms by the bottom because it has a plus sign on bottom. Same thing would be true if it had a minus sign on bottom. If it was x plus 6 or x minus 6, it has a plus or a minus sign, then we can't just straight divide like we did on those first couple of problems. So that is the real key that tells us something is different here. So we're going to go x squared plus 10x plus 24, and we're going to divide it by x plus 6. And once again, I'm just keeping this up here as kind of something we can refer back to. So I want to figure out x plus 6 and how many times it can go into x squared plus 10x plus 24. But what I'll tell you is my answer is not going to be just a basic whole number here. That'd be nice, right? My answer is going to be another polynomial up here. And then we're going to talk about, do these two polynomials multiply to get back to here, and is there a remainder left, basically. Okay, so long division is kind of a tedious process. But we're going to look at the first two terms. And we're going to ask ourselves, what do I have to multiply x by to get to x squared? What is it? X, yep. Okay, so I'm going to put that up here. I'm going to start with x. Okay, I'm going to take the number or the variable that I got here, and I'm going to multiply it by both of these. Kind of like I did with the 7. I took 7 times 4 to get 28, right? So I'm going to take x, but I got to distribute it to both of those things. So x times x is x squared, and then x times 6 is 6x. Okay, here's the part where probably most people get the most confused. When I took 7 times 4 up here, I got 28. But what did I have to do with the 28? I had to subtract it, right? So we have to subtract this expression from this expression. So what we're going to do down here is when we subtract this, we're going to distribute a negative throughout. If it's negative, we'll make it positive. If it's positive, we'll make it negative. And what that's going to do then is that's going to make these two cancel out. And then 10 minus 6 would be 4x. Okay. The big thing is you have to change the sign on both of these, just like I did with the 28, to subtract it. Okay, I'm going to bring down the 24. And the one thing we'll say about long division is it's repetitive. And we do the same process essentially over and over and over again. So now we're going to do the same thing as what we did at the very beginning. We're going to ask ourselves, x times what will get me to 4x? What do I got to multiply x by to make 4x? 4. Okay. So then I'm going to take this new number up here, 4. I'm going to distribute it to both of those terms. 4 times x is 4x. 4 times 6 is 24. And then, once again, kind of like we did here, we're going to change the signs on both of these. Negative and negative. And then watch what happens here. These cancel out. These cancel out. And so what we get is a remainder of 0. Now, we won't always end up with a remainder of 0. But what I'll show you here is, because we ended up a remainder of 0, these are the two, what we call factors of this, okay? And so to go back to what we did yesterday, if I were to take x plus 6 times x plus 4, if I foiled those two together, it would get me back to that. Bless you. So those two foiled together get me back to what I started with. If these two, if we had a remainder of something down here, I would multiply these two together and then add the remainder in, and that would get me back to here. Okay. Now, do you have to do that work? Do you have to show the FOIL and do you have to do all that? No. But I just want you to understand what the answer means. Okay. Kind of like what we did up here. 7 times 4 plus 1 gets me back to 29. There'd be a little bit more work involved here because you got FOIL, right? But it's the same idea. If I multiplied those two terms together, FOILed them together, And because we have a remainder of 0, I could add 0 in. It would get me back to here. Okay? So that's what we call long division. We don't do long division very often because we have an easier way of doing things. And it's called synthetic division. Okay, so what we have covered so far right here, that's the 5-4 part of the lesson. Okay, dividing monomials and then long division. Now this is starting 5-5, which still talks about division, and that's kind of why I combined the two together, because essentially we're doing the same thing. Okay, if we start off with x squared minus 5x plus 6, and we divide by x minus 2. We're going to do what we call synthetic division. Okay? And synthetic division is a lot cleaner, it's a lot easier, because basically what it does is it takes all the variables out of it. All you have is numbers when you do it. You still get to the same answer, you still get to the same result, but all you have to be able to do in order to do synthetic division is be able to multiply and add. If we can multiply and add numbers, then we can do synthetic division. So all of us can do synthetic division. And it's a lot easier. You don't have to worry about all the exponents and variables and all that. Okay, so first step is we're going to make this box out here, out in front. What goes in the box is the opposite of the factor. If I set x minus 2 equal to 0, I would get x equals 2. So 2 is going to go in the box. So you got to make sure you have the right sign on it. That's the most important part. Hey, then we're going to put all of our coefficients from the top next to this box. So we're going to do 1, -5, and 6. Make sure that all of your variables are accounted for. For instance, what we have here, we have 2, 1, 0. If I'm missing one in there, I got to include it. And I'll show you an example like that here in just a second. But I just want to make sure that we talk about that now. And I'll show you an example here in a second where it's missing an exponent and what that would look like. Okay, so now we're going to go through synthetic division, and we're going to get to our answer. Okay, we're still going to write our answer as a polynomial, but we'll talk about how we can get there. Okay, so the very first thing we're going to do is we're going to bring down the leading coefficient, which is 1, and bring it down here. Okay, and here's why. All you have to be able to do is multiply and add. We're going to take the number that's in the box, and we're going to multiply it by 1. So 2 times 1 is 2. Thanks, Mr. Frecking. And then we're going to add -5 and 2 together. And we get -3. And we just keep kind of repeating that process. Now I'm going to take 2 times -3, which is -6. And we get a remainder of 0. The last number on that bottom row is always my remainder. You're not always going to get a remainder of 0. I'll show you one in a little while that does not have a remainder of 0. So don't think that you'll always end up with a remainder of 0. Okay, the way that we write our answer. Our original polynomial started as x squared. This is going to be 1 degree less. So we're going to take the degree down by 1. So if I started with 2, we're going to write it as a degree of 1. And so I would write my answer here as 1x minus 3. And you don't necessarily need to put the 1 in there. We could just say x minus 3. That would be it. If we had a remainder, we would say x minus 3 plus whatever the remainder is. and then that would be part of our answer as well. Okay, same thing as what we talked about here just a few minutes ago. If I take x minus 3 times x minus 2, if I FOIL these two things together, it should get me back to this, okay? And that's a way you could check it. Do we have to? Do we need to? Not necessarily, but just understanding what this answer is telling me, that these two multiplied together would get me back to here. Just like when I divide something. If I take 10 divided by 2 and I get 5, 5 times 2 gets me back to 10, right? The only difference is here we're doing it with polynomials. Okay? Now I'm saying this times this gets me back to here. Okay, you guys kind of remember synthetic a little bit? A lot better than long division, for sure, right? Okay, let's do another one here. Okay, what number are we going to put in our box? 4. Okay, make sure it's positive 4, not negative 4. 2, negative 1, negative 5. All of the exponents are accounted for, and we've got all of our coefficients there as well. So we're going to bring down 2. 4 times 2 is 8. We multiply those together. And then I bring it up here. Negative 1 plus 8 would be 7. And then we just keep kind of going through the process. 4 times 7 would be 28. And we're left with a remainder of 23. This last number here is always our remainder. So the way that we would write our answer here is 2x plus 7. Okay, last year you probably wrote it like this. And that's the way you're going to see it written sometimes, is the remainder over the divisor, whatever we're dividing by. But if we were just writing our answer out, I would be okay with this. Okay. So either one of these are acceptable. This is a little bit different way of writing it. But I show you that first way just because sometimes, if let's say our answer is a multiple choice answer, or we're looking at our answers, then you might see it written like that sometimes. So I just want you to kind of remember that's one way that you might see your answer. Okay, let's look at one that's not a quadratic to start with. This one has a little bit different degree. This one is starting as a cubic polynomial. We have a degree of 3 to start with. Okay, once again, we want to make sure all of our exponents are accounted for, so we're going 3, 2, 1, 0. Everything's accounted for, starting at 3 all the way down to 0. Okay, so now we're going to set up synthetic division. Because it's x plus 2, we're going to put negative 2 in the box. Our coefficients would be 2, negative 5, negative 1, and 6. Okay. The only difference about this one is it's going to be a little bit longer because we got more numbers here. But everything's the same. And it's just a repetitive process. We're going to bring down the 2. Negative 2 times 2 is negative 4. Negative 5 and negative 4 would be negative 9. Negative 2 times negative 9 would be 18. Negative 1 plus 18 would be 17. And then negative 34. And I always draw a line in right here just to kind of separate it and say this last number is my remainder. And that would be, a remainder of negative 28. When I write my answer here, we're going to take the original polynomial and we're going to drop it down by 1 degree. So I started with 3, so I go 1 degree less. I'm going to start now with 2. So this would be 2x squared, and then you just keep going down by 1 degree, and a remainder of negative 28. And that would be our answer. Okay. So always just drop it down by 1 degree from where you started. Probably won't see much anything higher than a cubic. So quadratics and cubics are probably the two most common. Probably quadratics more than cubics, but we might see both. Okay, the last thing I'm going to talk about here is what we call the remainder theorem. And I'm going to show you a couple of different things on here as far as synthetic division goes that we have to kind of watch out for. If we were to evaluate a function, some function, okay, and we evaluate it at a certain value, then the remainder is the same as what we evaluated at, okay? And I know that kind of sounds like, what are we talking about? And I'll show you an example, okay? Because we've done this a little bit already, but we've done it one way, and I'm going to show you another way of evaluating and how we can use synthetic division to do that, okay? So if I gave you a function here, 3x cubed minus 11x minus 7, and I ask you to evaluate f of negative 3, what would be the way we would do that most common? How would I evaluate f of negative 3? Just plug it in. Yeah. Okay. So we're just going to go 3 times negative 3 cubed minus 11 times negative 3 minus 7. Okay, so let's put that into our calculator. Let's evaluate it. What do we get? Negative 55. Okay, everybody agree with that? Okay, so that's one way to evaluate a function, okay, and it's fairly easy, okay, and there's nothing wrong with doing it that way, but I'm going to show you another way to do it using synthetic division. And we call it the remainder theorem because we're going to take the number that we're trying to evaluate, which is negative 3. And that's the number we're going to do in the box. We're not going to do the opposite in this case because it doesn't say x minus 3. It's just negative 3. They're giving me the actual value. So that's the number that we're going to try to evaluate. Okay, now here's the other thing you got to be careful of. And we talked about this already, but we haven't seen an example like this yet. My degree is starting at 3, right? So we're going to go 3 because it's x cubed, but we're missing an x squared. Because we're missing an x squared, we're going to put in a 0 in place of the x squared. And then negative 11 and negative 7. And we're going to go through synthetic division. And if we go through all of that, notice what your remainder is. Negative 55. So my remainder will be the same as what I get when I evaluate a function. Okay? And the reason I show you that and show you both is just because if I ever ask you to evaluate f of negative 3, you could do synthetic division. I would say this would probably be easier, okay? But if you had to use synthetic division, or we talked about what synthetic division remainder would tell us, then it's just another way of saying f of negative 3 equals whatever the remainder is, which is negative 55. Okay, both of them get me to the same place. So you can use synthetic division to find a solution or to evaluate a function as well. Okay, that's all we got for today. I'm going to give you 2 page numbers, kind of 2 sets of assignments, because some is from 5.4 and some is from 5.5. So the first page is from 5.4. And then 5.5. There's not a lot or a ton of long division, but I do want you to try long division a couple of times, okay? I know you can do synthetic division to do those problems, but on 5.4, try to do long division a couple of times, and then on 5.5, we're strictly just using synthetic division, okay? So that way you have some practice on doing both.